So the series is given. We need to find an explicit formula for the sequence of partial sums, and we also need to determine if the series converges. So the general term, case term of this sequence of partial sum is of a series is the sum of first k terms. So the general term of the sequence of partial sum of this series is t k, which equals the sum from n equals 1 to n equals k of 1 over n times n plus 1. This general can be rewritten as the sum from n equals 1 to n equals k of 1 over n minus 1 over n plus 1. Then this equals 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4, and so on until 1 over k minus 1 over k plus 1. So here, as you can see, most of the terms kind of cancel out. For instance, 1 over 2 cancels out, 1 over 3 cancels out, 1 over 4 cancels out, and so on until 1 over k, which also cancels out. So we are left with 1 minus 1 over k plus 1. Well, so that means that the general term of sequence of partial sum of this series is 1 minus 1 over k plus 1. So sequence of partial sum is 1 minus 1 over n plus 1 from n equals 1 to infinity. Now it's known that the sum from n equals 1 to infinity of an equals limit of the sum from n equals 1 to k of an, where k approaches infinity. So that means that in our case, the sum from n equals 1 to infinity of 1 over n times n plus 1 equals the limit of the sum from n equals 1 to k of 1 over n times n plus 1, where k approaches infinity. Then this equals the limit of 1 minus 1 over k plus 1, where k approaches infinity. So we have substituted our summation notation with this expression which we have just found. So we get that this equals 1. That means that our series is convergent and it converges to 1. So let's write down our answer. So first of all, the sequence of partial sum is 1 minus 1 over n plus 1 from n equals 1 to infinity, and the series is convergent